Hello Matrix, welcome to another video, and we now finally end the sequences and series parade so far, at least for now. So maybe if in the future I come across some good questions, then perhaps that would be worth sharing. Then they can be shared. If you happen to come across any questions that you need assistance with, you've got two options. You can write in the comments here and direct me to the paper that you need me to do, or alternatively there's my email address attached onto this channel, so you can email me those questions that you need assistance with. Otherwise, we'll keep moving on to the next section from here. Alright, so we're gonna take our last batch of questions here from February-March 2018. Normally this is regarded as one of the tough exams. I don't know, we'll find out. Alright, let's get to this question 2 here. Question 2.1. We are given a geometric sequence. Alright, so pay attention. It's a GS. So once we talk of a GS, we know that we have to look out for the common ratio. It's quite very useful in such a circumstance. Now that it is 30, 10, 10 over 3, so we can see here that the common ratio is 1 over 3. Okay, because 10 divided by 30 is 1 over 3, and 10 over 3 divided by 10 is the same thing, 1 over 3. Okay, so it says determine n if the nth term of the sequence equals 10 over 729. 4 marks. Okay, then the next question says calculate. So once that is like that, you can see that there's no limit to the number of terms here. So this is a sum to infinity. Okay, very easy. We have a nice formula for that. Alright, let's deal with this 2.1 quickly. Put it aside so that we can move on. Alright, easy questions. So we are going to be dealing with DBE, Feb-March 2018, paper 1, question 2. Alright, not a problem. So in 2.1 we are given a GS, which is such that first term is 30, second term is 10, third term is 10 over 3, and then it keeps going. Alright, okay, not a problem. So 2.1.1, we are told Tn equals okay, let's not start there. I'm becoming silly now. So we know here that A equals 30, R, which is the most important guy, we know that it's 1 over 3. Okay, now note this 1 over 3 is less than 1, right? Greater than minus 1. Just so that you notice this one. So meaning we can find a sum to infinity for this geometric sequence. Okay, anyway, so we are told Tn equals 10 over 729. Now that implies what is Tn is A R n minus 1 equals 10 over 729. Right, which also implies what was A is 30, into R we got 1 over 3, okay, to the n minus 1 equals 10 over 729. not a problem. So here what we need to do, we can divide by 30. What is that doing? So we can divide by 30 here, and then we divide by 30. So whatever you do on the left hand side, you must do on the right hand side. This implies that we're going to have a third raised to n minus 1 equals. Now what is the story right here? So when we do that, this is the same as we are multiplying. Okay, let's just show this one nicely. It's going to be 10 over 729 multiply. So when you change it, divide to multiply, remember this is over 1, then it gets flipped around. Okay, and we know 10 goes 3 times to 30. Okay, so what we have here is 1 over 3 to the n minus 1 equals, now this is going to be 1 over, now 729 times 3 is 2187. Okay, no problem. So here you can have a bit of a challenge. You can do logs. I mean, it's up to you what you do here, but I just love the exponents. So I know that if I have that base, I can try and see if I cannot convert this to a similar base like that. So this is 1 over 3 into n minus 1 equals. Now let's see if we make the base 1 over 3, will we get something like this? Okay, so let's try and see what this can do. 1 over 3, so I'm just going to choose, this is an odd number, so I can choose any odd number in my mind. So let's say 3 to exponent 7, for example. Wow, see, now my gamble just nailed it on the head. Okay, not a problem. So you see exactly what we have is that. Okay, so we know this is 1 over 3 to the exponent 7. All right, not a problem. So yeah, this can be quite a challenge sometimes, but you need to know how to work things out. I mean, there are shortcuts, but sometimes you just have to work things as they come. Alright, so this implies, now you know that in exponents, once you have the bases having the same base, and you just take the exponents, it means that n minus 1 equals 7. Why? Because this is the same base raised this times. This means this is worth this number. Alright, that's what it means. Therefore n equals 8. Okay, not a problem, because that is what we wanted, wasn't it? Okay, not an issue at all. Alright, now let's just test it and be sure that it is so. So we know that a is 30 into a third raised, now n is 8. So let's see, when we say 8 minus 1 is going to be 7, right? So it's going to be to the exponent 7 over there, and we get exactly what they gave us initially. So this is good, there's nothing wrong with it. So someone here at this stage, from here, someone may say, okay, once I get here, I just introduce logs. So it's going to be log of a third raised to the exponent n minus 1. Whatever you do to the right hand side, you must do to the left hand side as well. It's going to be log of 12187. Okay, someone may just do that, and then the logarithmic rules say the exponent multiplies in front. Okay, so here you will have n. Okay, let's just draw this so that it doesn't mess up. N minus 1 log a third. Okay, equals that one, log 1 over 2187. And then we divide by log a third, log 1 over 3 all over log 1 over 3. And then we know this guy goes, then we remain with n minus 1 equals. Now once you do this, logarithmic rules say this becomes the base and that becomes the number. So this is the same as log of 1 over 2187 to the base 3. Okay, not a problem. So let's see what this is. Now you can just put in your calculator and say, okay, my base here is a third. Okay, easy. And then you go there, we have 1 over 2187. All right. Okay, now what do you get? 7. Nice. So at times you may struggle to think of what to do there. You can go this route, it helps you a bit. So you see, question 1 is nowhere, is going nowhere basically. Therefore n equals, you transpose the 1, becomes 8. Okay, this is just to show you what you could have done if you did not think of looking for the space in this expression. Alright, so they were giving 4 marks for this one. So I think what is important is getting our r, which was not quite obvious, and substituting into a correct formula. So I just made a complex situation over there. So that is good. And then I think this step is very important and the final answer. So this is where our 4 marks is. Okay, not a problem, not a problem at all. So I'm not gonna waste my time on this one. So we have our first 4 marks and it looks easy. And then the next question says calculate the sum of all those terms to infinity. This is also easy. So 2.1.2, we know here that s to infinity equals a over 1 minus r, provided r is in this format, and we know it is, we investigated it already. K, which will be equal to a, we got 30 over 1 minus a third. So this is easy. Here you just put into the formula what you have over there. You're not going to stress yourself by trying to imagine a lot of things. Sometimes reserve a bit of thinking for later. Okay, so I get 45. Alright, so that means this sum will converge to 45. Okay, no problem here. Correct substitution and the answer, that's the 2 marks. Okay, so we're good. Let's keep moving. We're doing a bit great here. So now 2.2 is what is in the textbook and what I have shown in my earlier videos on sequences and series. I don't know if I should do it. This is the proof for the sum of an arithmetic sequence. Alright, not a problem. So it says derive a formula for the sum of the first n terms of an arithmetic sequence if the first term of the sequence is a and the common difference is d. Okay, let's just do it for the sake of doing it. So 2.2, what we have here, the sequence, so the AS is in this form. It's going to be the first term. This is the sum, by the way, so plus the second term is going to be A plus the common difference, right? Right. Third term is going to be A plus twice the common difference, right? Plus dash dash plus. Now let's think about this one. Now we started with 3 terms, so let's do the last 3 as well. So the last 3 will be wait a minute, what is it going to be? It's going to be a plus n minus 2, right? No, minus 3, okay, times d, okay, plus a plus n minus 2 times d, okay, plus the last one, which is going to be a plus n minus 1 times d, okay. So these ones are very complex terms, so you cannot leave them flying like that, so that's why you need those big brackets, okay. So that is our AS, okay, let's just say SN, not give ourselves any problems. This is SN. Alright, so you know here that the next thing is you can write SN in reverse order. So here we start with our last term, which is a plus n minus 1 into d plus a plus n minus 2 into d, okay, plus the other one is a plus n minus 3 into d, okay, plus dash dash, and then we add those earlier 3 starting from that third one, which is a plus 2d plus a plus d, not seeing plus a, okay. So these ones cannot leave them floating either. Alright, let's solve them. Nice and easy, okay. Good, so with this setup, we know if we add both sides of the equation, what we get here is 2Sn equals. Now this is the same as if we're just inserting this into that. So what do we get as a result? So a plus a is going to give us 2a plus n minus 1 times d, okay, plus we move. Then here we're not just inserting a, we're also inserting d into this. So because these are going to add like that, like that, like that, and then that one, like that, and like that. So they add like that, alright. So now when we add an a plus d here, so inside a plus a becomes 2a plus. Now we need to break this bracket a bit. So this one becomes now nd minus 2d, okay, minus 2d plus d becomes a minus d, okay. Then we take out we take out d as the common factor, then we remain with n minus 1 into d, so it remains exactly like this. Alright, and then you can see that this is what will happen throughout. Okay, let's do the third one and then we stop. And then here again is the same story. We insert a, there we get 2a plus n minus 1 times d. Okay, why is it so? Because here when you break this thing, this bracket, you get minus 3d plus plus dn, alright? And then 2d minus 3d gives us minus d. Then we take d as the common factor, we remain with n minus 1 into d. So this thing will keep on going forever, alright? I'm not going to show that part. So what do we do now? We know that this implies 2Sn equals as many of these terms as we can get. So it's going to be n into 2a plus n minus 1 times d, because you can see that these become as many as you can find. Alright, so we divide by 2 here. Okay, this one divides the whole thing, by the way, so never make that error of making it look like it divides just one thing. So Sn becomes, now you know here you can either divide n by this and multiply the whole thing, it's up to you. So it's going to be n over 2 into 2a plus n minus 1 times d. And if you like, you can even further show that you can break this into the first term and the last term, but I mean, I think this is the target right here. So you're getting 4 marks for this. So I think expressing that Sn first in that manner and then putting it in reverse is also good. And I think showing this part is good. Okay, and then the last part is final. So 4 marks. Not a very difficult proof, but it can be annoying. So practice it as often as possible so that you do not find it challenging when it is asked in the exam. We knew that one or the other was there in our exams. So it doesn't seem to be the case with your exams. You can see a few papers without this, alright, or these proofs, but please be comfortable doing them. So that ends question 2, sorry. So question 2 was how many marks? That was 10 marks, okay, easy 10 marks. So where's the difficulty in a February-March paper? Well, we'll see, I don't know. Maybe this is just, to get us going. Okay, question 3. Question 3 says the first 3 terms of an arithmetic sequence. Now this one is an AS, okay? Once you are told AS, you know you're talking a common difference. Alright, so we have term 1 minus 1, term 2 is 2, term 3 is 5, okay? Now it says determine the nth term Tn of the sequence. Again, the general formula. So this is easy, so you should be finding it too easy. Question 2, we have 2.1, so not 2 but question 3, sorry. So we have 3.1, and here we are given an arithmetic sequence with minus 1, 2, 5, and it goes on. Okay, so now we know here that A equals minus 1, D equals 2 minus minus 1 is 3. 5 minus 2 is 3, so that is the story. So we know that Tn equals A plus n minus 1 times D, okay, which will be equal to minus 1 plus n minus 1 into 3, okay. This is minus 1 plus 3n minus 3, alright. So we can let 3n lead, and then there's one's minus 1 minus 3 is minus 4, and that's the answer, okay, not a problem. So how many marks? They're just giving 2 marks, so correct substitution and the answer is good enough, because they already told us this is an AS. If we had to discover it ourselves, D would be crucial to give a mark. Alright, so now it says calculate T43. Okay, the next question says calculate T43. That is question 3.2. So we know Tn equals 3n minus 4, right? This implies that T43 equals 3 into 43 minus 4. Therefore, T43 will be equal to, now 3 times 43 is 129 minus 4. I get 125. Alright, great. Not a problem. Alright, so here again, correct substitution into the correct formula, and the answer is just 2 marks. No problem over there. So let's keep moving. Now, the question says, evaluate the sum of the first n terms in terms of n. Now you wonder, where am I when I'm here? Again, you see the line of questioning still goes together with what we've been given. So basically this says we want the first n terms, the sum of the first n terms of this sequence, and we need to evaluate it in terms of n. Okay, once you see sigma, it says sum. Alright, so we're getting 3 marks. Okay, not a problem. So we know here that, okay, for 3.3, okay, we know here that A equals minus 1. We know that D equals 3. We don't have to stress ourselves in that sequence. So we want Sn in terms of n. Okay, so we know Sn equals n over 2 into 2a plus n minus 1 times d. Why are we using this? Because we don't know the last term. So the last term is just the hypothetical one. Alright, so we can substitute here and say this is n over 2 into 2 times minus 1 plus n minus 1 into 3. Okay, n over 2. Now we can sort this one out and make it into one bracket. So we have minus 2 here plus 3n minus 3. Okay, so what do we have here? N over 2 into, now minus 2 minus 3, so we have 3n minus 5 over here. Then we can multiply the n inside, so we get here 3n squared minus 5n. And you can decide now all of this over 2, or we can distribute the 2 for each. It's up to you what you want to do. Alright, so that's the answer again. Nothing complicated over there. So basically, how many marks? 3 marks. Okay. The correct substitution in the correct formula is crucial. And maybe that. I don't know where else I could give you a mark. Maybe to sort of further simplify that. Sometimes the marks are just all over the show. Okay. That is good. So maybe the 3rd mark would come from just recognizing that when you see that sigma, it means a sum. Alright? Maybe that is where the trick is. Okay? Good. Last question says, what is the story in the last question? It says a quadratic sequence, so always have these 3 sequences: arithmetic, geometric, and quadratic. So this one is almost always present, so know how to deal with it. Okay, a quadratic sequence with general term Tn has the following properties. Okay, so now we know for a fact that okay, let's start reading. What am I doing? T11 equals 125. Okay, Tn minus Tn minus 1. So meaning whatever term minus the preceding term to that, the immediately preceding term, we're getting that. So now when you look at this, ideally, if you had, for example, that tn minus 1 and you got a d, you would know this is an arithmetic sequence. But this one, what does it give us? If you inspect this other side of the equal sign, you can see that this is a linear sequence. And what makes a linear sequence when you have a quadratic? It is the sequence of the first differences. Alright, so this means this can help us to know the actual value of those first differences, and that can help us along the way to kind of solving this whole thing. Then the question says, okay, determine the first term of the sequence. Not a problem. We can handle that easily. 3.4. So first we are told that t, remember tn anyway, equals n squared plus bn plus c. So it's a quadratic thing. Now this would imply that t11 equals a into 11 squared plus b into 11 plus c. This would imply that we were told this is 125 equals, now what is that? 11 squared is 121a plus 11b plus c. So maybe we can call this one equation 1, because I mean that's what we have. Okay, so what do we know? We know that tn minus 1 equals 3n minus 4. And these are the first differences. This implies, okay, let's say we can say this implies that the first differences are going to be in this manner. It's going to be t2 minus t2 minus 1, alright? Equals, if you put a 2 there, you put a 2 also here. It's going to be 2 minus 4, alright? Great stuff. And therefore t2 minus 1, that is t1, equals, this is 6 minus 4, which is 2. Okay, you don't want to go any further here and cause yourself any problems, because you know now, okay, maybe you do need another one. You can say also, maybe you need just the second one. You can say t3 minus 1 equals 3 into 3 minus 4, right? No problem. Therefore, this is t3 minus t2, because 3 minus 1 is a 2. It equals 9 minus 4 is 5. Alright, so we are happy now. Okay, we are happy now. So we have a lot of work still. Therefore, we know here that 2a will be equal to, remember 2a is the second difference. Okay, let's not say that. Say this implies that 2a equals, we know now we need the two differences together. It's going to be 5 minus 2, right? Which implies that 2a equals 3, because that's what we do. The sequence of the first differences will help us to get there. Therefore, a equals 3 over 2 as a result. Not a problem. So what do we know? We know that the very first difference, it becomes t2 minus t1 in the sequence, in the quadratic sequence, which is 2. Okay, so this is good. We can deal with that. So we know that, however, we know that 3b not 3b, but 3a, which is the very first difference, plus b should equal 2, isn't it? Because we got it by taking the second term minus the very first term of the quadratic. So it becomes 2. Okay? And then this implies that 3 into 3 over 2 plus b equals 2. Now this implies that 9 over 2 plus b equals 2. Therefore b will be equal to, now let's just do that, but all I know is that I multiply, that one becomes minus 9 over 2, then I multiply the 2 to the 2, I get 4, minus 9, it gives me minus 5 over 2, okay? That is b over there. So when you transpose that, you get this one. Now what do we do? Okay, let's create some space over here so that we can work right on the same page. Okay, now what do we do here? We know that okay, let's just say substitute sub a equals 3 over 2 and b equals minus 5 over 2, okay, in 1, because now we want c. So it will be such that we have here 121 into 3 over 2 plus, remember that was the expression there, 11 into minus 5 over 2 plus c equals 125. Okay, that's what I'm doing there, which implies now we can deal with this one on the calculator. It's quite complex, okay? Alright, now 121 into 3 over 2 plus 11 into minus 5 over 2. Okay, now we can add those two together first, and then I get 154. Okay, so it means here we have 154 plus c equals 125. Therefore c will be equal to, now we will have here 125 minus that 154. I get minus 29. Okay, no problem. So what does this tell us? It tells us that Tn equals 3 over 2n squared minus 5 over 2n minus 29. Okay, now we were told we want the first term, therefore T1 will be equal to 3 over 2 into 1 squared minus 5 over 2 into 1 minus 29. Okay, therefore T1 equals, so you just put that in the calculator as well. Let's see what we get. Yeah, that was a bit of work, so maybe this is what they mean about yeah, but it's not really remarkable. I am yet to experience a bit of a challenge. Okay, let's not be too confident, we will die. So I get minus 30. Alright, so that is it. That is that. Alright, so it's good, and you can test this as well. Once you have this, let's see if we get our T11. T11, that's the only term we knew has 125. So let's see if this formula gives us that 125. So 3 over 2 into 11 squared minus 5 over 2 into 11 minus 29. Indeed, it's 125. So our formula was correct, so our A should be correct as well. Alright, that was a bit of work. So 6 marks indeed. It showed us a bit of work there. Alright, I think deriving this equation is good. And solving for these two guys right here. Maybe these two together. You can put this 5 together with this 2. Maybe say half a mark. Alright? To make 1 mark. So we have 2 marks over there. So the third mark is getting that. Yeah, we did need A. And we need this guy too. So how many marks do we have here? 1, 2, 3, 4. Oh. Okay. 5 and 6. Man, I don't know. These marks should be a little bit more. There's a lot of critical steps that we did here. But anyway, it's fine. Maybe you don't even get marks for these because, I mean, they were implied by this formula over there. Okay, guys, I hope you enjoyed this thing. And probably you've learned something. And now you can take challenge into those question papers that you have and your study guides and whatever. Please practice, and practice the most difficult of these questions. As soon as you feel like you can handle the simple questions, just, work on the very hard questions most of the time, so that your imagination, your way of working, the thinking process becomes a bit faster for you. And that way you'll become comfortable with these kinds of questions. Alright? I hope you've had fun, so we're going to move on from here. Bye-bye.